students, we are with 15.2. 15.2 angles in inscribed quadrilaterals. Quadrilaterals, any figure that will have 4 sides, like we have here. Now, first want to do a little bit of review, what we did in 15.1, and then eventually we're going to have all 6 the theorems that we're going to work with on the board. Last time we said inscribed angle theorem is the measurement of this angle A, or D, angle D. This one will be half of this measurement of the arc. So if this is x degrees, half of, and my arc will be 2x degrees. Half of 2x will give me this angle that will be x degrees. Okay, it can depend on, if we say that's 100, this one will be 50. That is 120, this one will be 60. We also had the inscribed angle of a diameter theorem. What did that theorem state? If I have a diameter, it's a chord, special chord going right through the center of a circle. I know that any angle that starts at the endpoints of the diameter, doesn't matter where I draw that angle, doesn't matter where, it will always be a 90 degrees angle, because this one here at the center is 180 degrees, and the one on the circumference must be half of it. Now we're going to work with quadrilaterals. If I have a quadrilateral here, A, B, C, D, E is my quadrilateral. The end points is on a circle. It's an inscribed quadrilateral. It's not any one. The end points, the vertices of this quadrilateral must be on the circle. Then we have special qualities here. This angle A, the measurement of angle A plus the measurement of angle C, the one opposite, will always be 180 degrees. There's a proof for that, but we're not going to go into the proofs. So angle A and angle C is not equal, different angles, but if I add them, the answer is 180. They're supplementary. Angle D and angle B is not the same size. They're actually different from what the rest was, but the measurement of angle B plus the measurement of angle D, whenever I'm working with an inscribed quadrilateral, where that's on a circle, these two opposite angles will always give me 180. So opposite angles are supplementary. 180 degrees, the word is supplementary. If I add them, I get 180. The angles must be on the circumference of a circle. The next theorem is the converse of this one. So here you can see we don't have a circle, but we do know that the measurement, let's say, the measurement of A and the measurement of C, A and C is definitely 180. No circle that we can see. We can also see they give us that B and D, if I add this, I will definitely have 180. What can we state afterwards? We can say that the vertices of this quadrilateral will lie on a circle. So let me just quickly get the right correct wording. A, B, C, D, A, B, C, let's put an and D lie on the perimeter, or we can say the circumference of a, do you know the symbol for a circle? Has a little dot in the middle. That means circle. Okay. Right, let's carry on. The next one. Congruent corresponding chords. Remember what's a chord? A chord and a chord is lines with endpoints on a circle. So we must work in a circle for this theorem to be true. If we know that the measurement of the arc, look at the little bow, arc. So let's make this one the red one. And it is congruent, exactly the same size as this blue one. C to D, the two arcs are definitely equal. What can we state? We can go and say that this chord from A to B, let's make it a red one, from A to B, the right straight line chord is also congruent to, from C to D, the chords. So if the arcs are equal, the chords will also be equal, that are formed by the same endpoints. And the sixth theorem for this session will be the converse of what we have there. We still have a circle. This time we're going to start with, and we're going to say, this chord, the blue one, CD, is equal to this chord. They are congruent, the red one. What can we state? We can go and say that the measurement of AB, the arc, this one, will be equal to, it's not just equal, it's congruent to the measurement of the arc, CD. Okay. So I can go and say this one will be equal to that arc. And if I go back to the previous sketch, we can also say that this chord will be equal to that chord. Okay, here's our 6 theorems. Take a good look. We're going to work with them.